Where I hit the button. So this is number 3. Yeah. All right. Uh, you're not as lost as you think you are, first off. Okay, so here we go. First thing we're gonna do, we're gonna find a. Uh-huh. I'm gonna say this on the recording, because this question came up apparently not in this class. You cannot reduce like you want to. And this, I love this question. It doesn't always come up, so I just usually don't bring it up if no one else does. But like if you look at number 1, aren't you inclined to want to divide everything by 2? You can't. The reason we've gotten away with this in the past is because the other side of the equation had a meaningless 0. So really, Cody, hang on a second, okay? Really think about what's happening here. That when you divide an equation where one side says 0, you get away with it because the 0 gives no craps, right? However, if you divide that equation by 2, then your equation, so like if I'm talking about number 1 here, your equation would now say y divided by 2 equals 1x squared minus 10x plus 24, right? Which is rad because the numbers are smaller. But then since the y is not by itself anymore, we'd have to turn right back around and remultiply it by 2. Bottom line is the fact that it says y equals is very significant, and we can't do anything that makes it not say that. Does that answer your question? Longer answer than you wanted, but it's a really important question. No, you may not. With these, you get what you get. Yes. Yep. Yep. I mean, I don't mean to be short, but I didn't write the problems, but the computer wouldn't write you one that had the vertex already starting off the graph and then going off the graph. So yeah, you done boo booed. All right, so here we go, finally. You agree that finding A is easy and that finding B is easy? Okay. So are you struggling with the negative B over 2A part? Yeah. Okay, so if we do negative B over 2A, it will say negative B over, good for you. And then if you copy dot flop, oh, you got lost here? Yeah. Oh, happy day. This is easy. This is an easy fix. Copy dot flop. So instead of writing it as negative 3 halves divided by 1/2, because that's what this really says, right? You get that. And then we just go, oh, I'll just copy dot flop it. So we go negative 3 halves times 2 over 1,
So it would be negative 6 over 2.
which is negative 3.
Yeah.
Right. So having said that, we now know that the vertex is at negative 3, comma, blank. So we're not quite out of the woods. We have to now go back and do some plug and chug, as we used to say back in the day. So I'm going to take my negative 3. I'm going to put it right there. And that's going to be a fourth of 9, because negative 3 squared is 9, right? And then I'm going to take my negative 3. And I'm going to put it right there.
3.
3 halves of negative 3 plus 9/4. Good.
Yeah.
And then the rest from here is just going to be a whole lot of just old school basic math. So for this first one, there's nothing about it other than just to go 1 times 9 and then put it over 4. Okay. Is that okay? You sure?
Yeah.
Now the second one, I'm going to do this times this, which is negative 18. Good. And I'm going to put it over 2, which is actually 4. So the reason I did that was because I doubled what you said. Because you were going to give me negative 9 over 2. And I knew I needed this bottom to match this bottom. So just kind of using a little bit of foresight along the way, knowing, just kind of looking a step ahead. I was like, I know you're going to need to be doubled to get your bottom to match the other guy. So that's why as you go, it's okay not to do it as you go, and it's okay to do it as you go. But it might wind up saving you some time in the end. Maybe not.
Okay.
Good. And then the last fraction, I don't have to change. He's just a normal plus 9/4. So since we did our due diligence and got these bottoms all to be the same, then all we have to do now is just go and do this math problem that's in this green pickle thing, whatever. So you go 9 minus 18 is -9. -9 plus 9 is 0. So we now know that the vertex is at -3, 0. That's a lot of work to come up with a 0, but oh well. So now that we're about done mathing here because I can go to -1, 2, 3, 0, put my vertex. And now the only thing that matters is the number in the purple box. You get that, right? That once we obtain the vertex, all this other stuff gone. Now I just go to my vertex and I go out 1, up a quarter, out 2, up a quarter of 4, 1, out 3, up 2.25, so on and so forth. We just keep taking our normal 1, 4, 9, 16 and dividing them by 4. Got it? Right. Yeah, man. Um, so if I multiply those two purple numbers together, I get -9. Well, here, I'll just put it right here. I get -9, and then I just put it over 2, right? But you know, with adding fractions that the bottoms have to be the same. So I find myself as I'm going a lot of times that I just do it as I go. Like if you look ahead about 10 seconds in the future, you know that the fraction in the middle is going to have to play with these two fractions that have 4s on their bottoms. So you're like, I'm just going to make your bottom a 4. And how we do that is by doubling the top and the bottom. Good. So I guess since I'm recording, I'll just finish up the graph with you. Okay, so let's head over to our vertex and I'll zoom in on it. And our builder number is a 4th, right?
Great.
So the key here is just to remember, what would I do? Divided by 4. What would I do? Divided by 4. Keep doing that. So I would go up 1. I'm going to divide it by 4. And then I would go up 4. I go divided by 4. I would go up 9, but 9 divided by 4 is 2 1/4 in there.
And then it would be 4 and
Nice job. Normally 4 would be 16. We're only going to go up 1/4 of that, which is right here. And we can actually do a lot on these. Like I said before, these fat graphs, you can do a lot of points. Yeah. I'm just writing it down. Go ahead.
but then I run out of
You will run out of room. That's what happens, is that eventually you run out of real estate, and that's normal. So I'll do a couple more to get caught up to you here. So if I go out 5,
you can keep going up, but ours only will not.
oh, because your graph is smaller than mine. To like, okay, so but I mean, so where are we at? I think we're almost there, right? So if I go to, let's go left 5. So
Okay.
1, 2, 3, 4, 5 would be 25. A fourth of 25 is 6.25. 4, 5, 6.25. And I think you could do one more, because if you're saying your graph goes to -8, I'm going to circle -8. I believe it's right here. So that yellow thing right there, I believe is -8. You are right, and I can't count. That is -9. So I believe then that you're out of room. You could do some more probably to the right, or no,
Yeah, you can go more to
but you
right.
probably can't go up much more, can you? Yeah. So listen, you're all big kids, and you know what I mean when I say this. Put as many points as you can on the graph. Uh, and your graph is different than mine. I forgot about that.
This is what I was gonna get.
Wait, so we have number 4. We have y equals negative 1/2 of x squared plus 5x minus adjuster fixer. So A is negative 1/2, B is 5. So if I plug into my happy little purple bestie formula, negative B over 2A, it's going to say negative 5 over 2 times negative 1/2, which is negative 1, which means the vertex is at 5 something. Yeah, okay, good. So now that means that we have to put 5 back up into the original, the quadratic function. So if you put 5 in, and there are a lot of times where mistakes happen here, I think what happens is people fail to embrace the order of operations. It doesn't matter what grade you teach, people sometimes just forget. So you have to respect the fact that that goes first. Yeah. So if I put 5 there and I get 25, then if I take negative 1/2 of 25, I get negative 25 halves. Are you okay with that?
How'd you get 25?
Because I put this 5 right here in place of that x, and 5 squared is 25. And then negative 1/2 times 25 is 25 over 2 with a negative on it. You good?
Yeah.
And then this next part is going to require, again, anyone kind of casually watching right now might get lost and not know what I did, but it might be worth it to just kind of watch what I write as compared to what I say. Are you ready? So in the second part, when I put my 5 right here, the answer to 5 times 5 is 25. I know it's weird, right? It's like I said 25, and then you're like, oh my God, is he having a stroke? But it comes back to that same idea. It's just using a little bit of foresight. I say, I know eventually you're going to have to be a fraction with the bottom of 2. So I just jump on it while I'm there, right? You better? And then you see after this why the minus 31 halves is not your enemy. Quite the contrary, right? So when I do this math up here, I know that the answer is going to have a 2 on the bottom. And then when I do the green caterpillar, I go negative 25 plus 50 is 25. 25 minus 31 is
Whoa.
25 minus 31 is negative 6. And then you realize, thank you, Mr. 31 over 2, for bringing me back down to the ground here. It makes it a nice negative whole number.
Okay.
Isn't that pleasant? Yep. And then we know our vertex. So we're going to go to the right 1, 2, 3, 4, 5, and down 1, 2, 3. And then tell me about this graph with the builder number is right here, right? So I'm building with a negative 1. See, good job. So yes, it goes down. We can agree on that.
Yeah.
And what else can we say about it? Slightly chunker. This isn't a full-blown chunker, but it's slightly enlarged because all of his y values are going to get right. So when I go out 1, how far down am I gonna go? Nice. And when I go out 2, how far down am I gonna go?
2.
Nice. When we go out 3, how far down are we gonna go? 9 cut in half. If you and Morgan were going out to lunch and you had $9 at the bell, yes, you could each spend 450, right? Good job. So we're gonna go down 1, 2, 3, 4.5. And I do think you're probably out of room at that point. Just a hunch.
Yeah.
And then you're gonna do your very best. Oh, I tell you what, that's a pretty good parabola that I just, oh, I don't want to jinx it. Oh, well, I'm sorry, but that's a really good one. Look at that thing. Look at that. Just marvel at that. That thing. Look at what I've done. Oh.
Yikes.